This is part 3 of section 4.4. I want to solve this equation. The first thing I want to do is I want to try to get this natural log by itself. So I'm going to subtract 7 from both sides. And that gives me 3 natural log of x is equal to -1. Okay. Now I'm going to divide both sides by 3. So I end up with natural log of x is equal to -1/3. Now don't freak out because I have a negative number here. It's only the argument of a natural log that cannot be a negative number. Okay? Now what we're going to do is we're going to switch this into exponential form, which requires you remembering that this is base e. So this is going to come over here and bump that up to be an exponent. So my x value is e to the -1/3. Okay, so this is approximately e to the -1/3 is 0.1, we're wanting 2 decimal places, so 0.72. Now, is this a legal value for our x here? Yes, it's a positive number, and this argument does not require that we add or subtract anything to it, so it is a good answer. Okay, so let's try this last problem. Here we have multiple logarithms and multiple ones that have x's in their arguments. We are going to need to use our properties to combine at least these two into a single logarithm. Okay, so let's, we can actually combine these two, right? What we have here is this property right here. We have 2 logarithms with the same base. Now these are common log, which remember log x means log base 10 of x. Okay, but I have the same base here, which means I'm allowed to combine them by multiplying their arguments together, multiplying them together in the argument. So this is log of 2x minus 1 is equal to log of 3 times x plus 3. Now, it may help you to put that in brackets right there because all of this is the argument of that log. Okay, well, I said we want just one, and we can do that because I could subtract this to the other side, and then I could use this property. But the other thing I can do is I can use this. Okay, since I have a logarithm equal to a logarithm with the same base, one thing I'm allowed to do, one way of thinking about it is you can just drop your logs and your arguments have to be equal. But what's really happening here is I'm calculating 10 to the log, common log of 2x minus 1 is going to equal 10 to the log, common log of 3 times x plus 3. I'm allowed to do that, raise 10 to that power. Because if their powers are the same, then it should be the same. And then we have this, where our base of the exponential and the base of the logarithm are the same. So this should equal just our argument. So what I end up with here is 2x minus 1 is equal to 3 times x plus 3. Okay? Yeah. So practically speaking, if you end up with a log equal to a log, no other thing added to it, not a +4, I had to combine these before I could do this. It has to be a single log equal to a single log. And if they have the same base, then you are allowed to just set the arguments equal to each other. So let's solve this. I'm going to distribute the 3. (2x plus 1) is equal to 3x plus 9. So let's subtract 2x from both sides and subtract 9 from both sides. And that will give us negative 10 is equal to x. Okay, now, so I have an x value. This is my only potential solution. Does it work in the domain of these? Well, let's do this one first because it's easier. If I plug in negative 10 here, I have negative 10 plus 3, which would be negative 7. So I'd need to take log of negative 7, which I cannot do. I must throw this answer away. Okay, now it happens to be wrong in this one as well, but it is possible that your potential answer is wrong in one of them, meaning not in the domain of one of them, but is in the domain of the other. If you have a problem with any of the logarithms, if you get undefined in any of them, then you have to throw out that answer. This is no solution. Okay, this particular equation has no solution. It is impossible. Now what I'm going to do is I'm going to put in an extra video, and I'm going to rework some of these problems using a different approach, just so that you have an idea of what is possible and what is not.